Hello, students. Had a couple questions come in out of the homework from 13.5. So let's tackle those. First question was 4D and E, which I think is, here's question 4. Let me make sure, part B, 4D and E. I think sometimes these get, they start looking intimidating, but really when you have a shape like these, where you know that it's just the area of the base times the height to get the volume, because that's what we're looking for is the volume. So you just find the volume by doing the area of the base times the height. When you have a shape like this, you could certainly break it all down and say, okay, I'm going to break it down. So I have a triangular prism, and then I have a rectangular prism, right? And then I just go through the formula a couple times. And you could certainly do that. But what you could also do is say this whole thing down here is like the base, and then the height is going that direction. Because that way you're just thinking of stacking the same thing on top of itself. So that would be my recommendation, is to go ahead and find the area of the base, multiply by the height. And so if you need to, again, the base, sometimes people think the base has to be the thing you're sitting on. And so they would think that, oh, the base is the 30 by 40. No, the base is whatever you determine the base to be. So here the base has to be the circle, and that's because then I've got the sides and I have this other circle up here. But in a shape like D or E, yeah, you get to choose. You get to choose. So here in part A, you could have chosen this to be your base. There's my base, and then this is my height going that direction, and you're going to get the same result, which is kind of cool. So I'd say probably for D and E, I would treat, see how you got this kind of long piece and it's the same cross sections the whole way. So again, just think of the base being this piece at the end and say, here's the base. So if I can find the area of that, then I am on my way. So I think what I would probably do, here, I'll make a little bit of white space. Is I would just take this cross section at the base and say, okay, I have this triangle. Like for this one right here, I have a triangle, and then I have this rectangle. And the rectangle is 30 by 15. Okay, so you can multiply that. That's not too bad, right? 450 square feet. And then the triangle above, it's base of 30 and a height of 8. So this is 1/2 times 30 times 8. So what I'd probably do half of 8, because that gives me 4 times 30 is 120, so that's 120 square feet. And so then just add those together and you have 570 square feet, and that is the area of the base, because now we're treating this as the base. And then the height is just this piece right there. So then multiply by 40 feet, and that's the height. And so the volume is area of the base times the height. And same thing for this bottom one. Same thing for this. Oops, I guess I need a little bit of white space again. But yeah, same thing for that bottom piece. No reason to do too much different there. Just break it up into chunks and individual pieces and go from there. So here I have a triangle. Oops, bad color. I have a little bit of triangle on top. And let's see here. What do I know? Oh, yeah, I know the base and the height. So that's perfect. So you know that this top triangle that looks like this has a height of 6 and a base of 10. So it's 1/2 times 6 times 10. Okay. Then I have a triangle that looks like this, and I have another triangle that looks like that, and then probably a rectangle here in the middle. And the rectangle in the middle is 10. And actually these two pieces, I mean, you could really push them together so that it kind of looks like one triangle. Why not? The height, it says, is 8, and the whole length is 50 with 10 taken out of the middle. So that means the base is 40. So I have this one, which is 10 by 8, and this one is 8 by 40. So 1/2 times 8 times 40. This one right here is just 8 times 10. So all I'm doing is breaking up and say this piece I have. This piece is here. These two pieces are here. And then the last piece is this big rectangle, which, I mean, looks crazy, but is really just a rectangle that's 50 by 20. And so that one is 50 times 20. And that takes care of that piece. And add all of these up, and that becomes the area of your base. And then you just say, here's my height. My height is 60. So that's what I'd recommend. Try it that way. Okay, let's see here. Let's jump in and we're going to go to number 17. A heavy metal sphere with a radius 10 centimeters dropped into the right circular cylinder with a base radius of 10 centimeters. Okay. If the original cylinder has water that is 20 centimeters high, how high is the water after the sphere is placed in it? Okay. So what we need to know is the volume of that heavy metal sphere. And so this comes back to just volume. And we know the volume of a sphere is 4/3 pi r cubed. They tell us the radius is 10. So we can go ahead and check that off. And again, that's the volume that's going to increase. Then what you have to say is, well, wait a minute, that's the volume when I calculate that number, right? And that volume is a base times height when I put it back into a circular cylinder. Now the base is the area of the base, so pi times r squared, and the radius is 10 centimeters, so 10 centimeters. So what you'll do is if you go in here, you'll know the volume, you'll know the radius, the only thing you're missing is the height. So you solve for h. Solve for h. Pretty cool. Oh, and by the way, leave the pi in there the whole time, because once you have pi on the left side and pi on the right, the pi's are going to go away. So don't turn it all into decimals. So yeah, solve for h. Once you have h, that tells you how much the water, how high the water went up. Okay. And so if you knew it was 20 centimeters high to begin with, now you know how much it went up. It says how high is the water after. Okay, so just think, we don't know the height of the cylinder. We know that the metal ball is basically roughly the same size as the cylinder, so it'll kind of sink down here to the bottom and just be sitting down here at the bottom. So if your water was here and you put that in, now all of a sudden the water is going to be obviously higher. And so it was 20 centimeters to begin with, and then what is it going to be after? There you go. Let's see here, and then MC7. Yeah, this links back to like the Pythagorean theorem. Yeah, so you could actually use the three-dimensional Pythagorean theorem. So I talked about that in one of the videos that I made. Let's see here. Let's get a little bit of white space here. Okay, here we go. So now, yeah, this three-dimensional Pythagorean theorem is pretty cool. But like if you had some type of rectangular box, right? You probably want your shape, like the longest shape you could have would kind of go from one of the top corners, like down to a bottom corner, this kind of diagonal, which is great, but like your box itself, like that's like a diagonal of the box, not a diagonal of one of the polygons. And so what we'd have to do is we'd have to create, like we'd have to know to use the Pythagorean theorem, we need to know this piece down here in the back, which again, it looks like we know that. And we need to know this length going across the diagonal of the base so that we would get a right triangle and we could find the hypotenuse. And so if you think about it down here, whatever your side lengths are, let's just say they're A, B, and C, then right here in the bottom one, in order to find this diagonal, we would use the Pythagorean theorem on like a little right triangle in the base. So now think about the base of this, which has C over here and B over here, and we're trying to find this length. Then with a right triangle, that length is like B squared plus C squared is equal to whatever we want to call that, D, is equal to D squared. Which is great, right? Totally fine. And honestly, if we wanted to solve it, we would just say D is equal to the square root of B squared plus C squared, because we know it can't be negative, because we're talking about length. Okay. Let's see here. D, so that takes care of that piece. And then this height is A. So now bring it on down. And I have A. And I have this piece, which is D. And now I want this length, and this length I'll put in blue again, just going to say that's the piece I actually want. That's the longest piece that can fit in my box. And I don't know what that one is. Maybe we'll call it E. So what do we have? Right triangle. So A squared plus D squared equals E squared. And here's where the fun comes in. D squared is B squared plus C squared. So just substitute. So what is E? It's the square root of A squared plus B squared plus C squared. And there you go. So you can find the length. Just grab your numbers and apply it and see which of these will actually fit a 37-inch long umbrella. And those are the big pieces. All right. Hope that helps. Let me know if you have other questions. Off you go.